All right, so can everyone see it? My screen? Cool. All right, I guess we can go ahead and get started. Let's see. So welcome to the Tplot Essentials webinar. I'm going to try to record my voice as well as the screen here and hopefully post my voice and the screen and the video of the screen on YouTube after this is done. And so feel free to please mute your phone through the presentation. But if you have any questions, feel free to unmute and ask away. Just go ahead and interrupt me anytime. And I'm going to go through this crib sheet step by step. And the crib sheet is going to be in the SPEDAS distribution under the projects folder, MMS, examples, webinars, and it's called Tplot _essentials _MMS August 18 for August 18th. And if you don't want to ask questions throughout the presentation, my email's at the top of the script, so you can always email me later as well. So the plan is to just go over the very basics of Tplot for those of you who aren't as familiar, to go over some Tplot options, and then see, someone is asking for that I can go. I'm going to go ahead and reply to this email so they can join as well. Let me find the meeting ID. Here we are. So we're going to go over how to set Tplot options, how to set plot options with Tplot, and the various tools for doing that. Tplot tools for working on Tplot data, how to export data using various methods, and we're going to cover saving figures. So saving Tplot figures. So I guess just jumping into the basics, we're gonna load data from FGM, FPI, and MEC. The MEC is the MMS ephemeris and coordinates data. And actually, let me do a full reset the session, and then we're gonna run. So for those of you who aren't familiar with Tplot's an object-based system. So we have the data is carried along in objects, which means we have data as well as metadata about the data stored in the variables. And there's a program called Tplot that actually creates plots of the variables using both the data and the metadata. So just as an example here, I created a simple plot of FGM burst mode B vector data. Then I dragged the figure up to the upper left, and so once you create a plot, you can grab the bottom right and move it around to resize the window, and then you can call an empty called Tplot, and it'll redraw the window to the current size. So I went ahead and just resized the window to fit in the upper left. So one of the most useful routines for finding which variables are loaded in Tplot is Tplot _names. So what that does is list all of the current Tplot variables that are loaded into memory. And it also includes their number, includes their variable name and the variable number. And so you can see just from loading FGM, FPI, and MEC data, we have 172 variables loaded. So sometimes you want to limit those variables to only the ones, say for one instrument. So the Tplot _names, if you don't give it an argument, it lists all the variables loaded. If you do give it an argument, it lists only those that match the pattern. So stars match any kind of characters or any characters. and a question mark matches a single character. So if you call tplot underscore names and then star fgm b star, it'll only list the b variables, or the magnetic field variables. And I showed earlier that you can just call the tplot with the variable name. Another way to call tplot to create a plot is to give it the numbers instead. This is what I use most of the time. I just rely on the numbers rather than typing out the variable names. And so in this example, we plotted variables number 12, 14, and 16, which are just the B field data in different coordinate systems. That's the DMPA, GSE, and GSM. And if you're actually getting the tplot variables in a routine for some reason, like you want to load them into a variable or a list, we have this routine called, or this function called Tnames, and that actually returns the list of variables, so you can easily store it in a list. So in this example, I just created an array called Tn of all the tplot variable names and then printed them off. And like tplot underscore names, Tnames accepts an argument that can limit the number of variables, or the type of variables based on the pattern of the variable names. So in this example, I loaded an array of all the tplot variable names that have FGMB in them. And another useful trick is to the tplot routine accepts the add keyword. That's allows you to add a variable to the top plot, or to the top of a current panel. So in this example, I'm going to add. We already have the DIS energy spectra loaded. I'm going to add that spectra variable to the top of the current plot. And you can see just adding the add keyword went ahead and added it to the top. So to actually get data out of a tplot variable, you use get underscore data. And the keywords are data, delimits, and limits. The data is returned using the data keyword. The delimits are the metadata set by the load routine, and the limits are the metadata set by the user using options. So there's a routine called options that allow you to set options, various metadata on variables, and all of that stuff is stored in what's called the limits. So for instance, we can call get data on our omnidirectional energy spectra, and if we call help on D, so D is going to be the data, and it's just an ideal structure with 3 tags. The X tag, and that's the times. The Y tag is the actual data at each point, and the V tag are the energies, since this is energy spectra. So you can say D dot V, the first energy tag. So this first element here is going to be the time. See, there are 400 times and 32 energies. So the energy table for the first time is between around 2 eV to 28,000 eV. It's close to 30 keV. And the reason that this varies each time is because the energy table for this data product actually varies with time, or it should. And so you can do this with any of the variables. I did it with the energy spectra variable, and now we're trying it on the FGM variable. You can see with the FGM variable, since it's not an energy spectra, there is no V for that extra dimension. We only have X for the times and Y for the data points at each time. And X, or that first element, and Y should match the number of X values, because you want one Y point at each time. And to show what the delimits returns, there's all kinds of stuff in there because it's the metadata that's set by the load routine. So that includes information like, is it a spectrogram? Should it be on a log scale? The labels, the Y subtitle, the colors, and all of the metadata from the CDF is actually stored in an IDL structure called CDF. So for the variable attributes that were loaded in from the CDF file are actually stored under dl.cdf.vat. You can see the ISTP variable attributes are for this variable are stored in there in case you ever want to go in there and look at something. And the opposite of get data is store data. Store data allows you to create new variables using IDL structures. So in the next example, I'm just going to use store data to create a new variable called new FGM VAR. And we're going to use the same delimit structure that we used from the get data earlier, and the same limit structure. And we're actually going to, instead of saying this data equals D, which would work, we're going to create this structure on the fly. That way you can see how it actually works, which means, let's go ahead and create it. So you can see I gave an open braces an X, which means the X tag is going to be these values, and then comma, and then Y, which means the Y values are going to be these values, and then a closing brace means to end the structure. So this is essentially just creating a new structure with an X tag and a Y tag, and then passing it to the data keyword. And what that did was create a new variable called new FGM VAR. And you can see, we can go ahead and plot that by calling Tplot 173. And since we used our delimits and limits from before, it got the metadata correct and the Y title and the colors and everything. So if you leave these off and just create the variable without any metadata, it'll probably get the colors wrong and the labels wrong, so you'll have to update that. And I'll show how to do all of that under the Tplot options section later. So one more tag that's really useful is the dy tag. So there's an X tag, a Y tag, a V tag. But there's also a dy for adding error bars to your Y values. And so it just so happens that the DIS number density data has error bar data. So the next example, we're going to use get data to extract the number density data into an IDL structure and the number density error data into an IDL structure. And then I call store data to create a new variable called DIS number density with error. And so for the delimits for the metadata, I just passed the same delimits from the number density variable. Same with the limits. And for the data, we give it the density X values, the density Y values, but then there's the dy tag, and you give it the error values, which are the Y values from the error variable. And you can see we created the variable and then called tplot with the variable name, and it created a plot of the density, and you can see that the error bars are added now. So those error bars actually came from this number density error variable. And in the call to tplot, I used the T-range keyword to zoom in, because it's kind of hard to see the error variables if you're zoomed out. So you can see the error data here. So another way of zooming in, or the first way of zooming in to Tplot data, is just using the T-range keyword and you're called to Tplot. So some more useful routines for working with Tplot variables. We have copy underscore data, which copies a variable to a new variable. So it's just copy and then give it the old variable name, and then the new variable name, and essentially just creates the new variable from the old variable. There's also del underscore data for deleting data. So I created this copy essentially with the same name as before, except with underscore new at the end. So then I'm gonna delete the old variable, which was new FGM var. And I went ahead and deleted that, and you can see in the console it deleted that one variable. And delete underscore data also accepts wildcards, so you could say star here and it'll delete all of the data that you have loaded. Another useful routine is average underscore data. That'll average the data in a tplot variable. And I think the second so the first argument is the variable name that you want to average. The second argument is the number of seconds. And then you have to give it the new name keyword to actually create or to tell it the new name of the variable that you want the average data to be stored in. So in this example, I just tell it to store the average data in the same old variable. So you can see it altered the tplot variable there with the average data, and went ahead and plotted it. Actually, it plotted the the number density data, but we can easily go plot this instead. So this is the averaged B-field data. So when you have a vector and a tplot variable, one useful routine is to split the vector into its components. So for that we have split underscore vec, and you just call it on the variable. What it does is create three variables from the three components inside that tplot variable. So it created an x component, the y component, and the z component. Then I called tplot on the components, and essentially just plotted the x, y, and z. And just a heads up, what this is doing here is creating an array where the first part of each element is the old variable name, and then at the very end we have x, y, and z. So it should show this is actually a 3-component array, x, y, and z. And so the opposite of split vec is join vec. So you can take 3 components and join them into a new variable, essentially a vector variable. So you give it the array of components first, and then the name of the output, and it should combine those back together. And you can see we have, on the top panel we have the vector plotted again. On the bottom 3 panels we have the x, y, and z components. So most of the information for the basics, that's pretty much enough information to get you started doing pretty much everything. So now we're going to jump into the tplot options. So for this plot, I plotted the FGM data that we created the last time, and I plotted the energy spectra from before, the ion energy spectra. Let's go ahead and create a much larger plot. And if you look in the bottom right, by the color bar, at the bottom of the color bar, there's a timestamp of when the plot was created. That is controlled with the timestamp routine. So you can turn that timestamp off just by calling the off keyword to that routine. So if you call timestamp with the off keyword and then call tplot again, notice the timestamp at the bottom is gone now. And so you can drag that back up and call tplot to resize it. So there are 2 different ways of setting options in tplot. There's a routine called tplot underscore options, which is more of a global options, And then there's just options, which allows you to set options on independent tplot variables. So, for instance, if you want to set the X margin, margin in the X direction on all the tplot windows you have open or in the current session, you use tplot_options X margin, and then give it the margin, the left and the right margin. So we'll go ahead and do that and show that. So that added 30 character margins to both of the X sides, the left-hand side and the right-hand side. You can also call just options and then give it a tplot variable name, and then give it X margin and X margin, and it'll only set the X margin for one of the panels. But generally, if you're changing the margins, you want to change it using tplot options, using the global one, so all of your panels are lined up. So, an example of using the options command. In the next example, we're going to change the character size to 1.5. And options accepts not just strings of the tplot variable names, but you can also use the variable numbers that I mentioned before, as well as an array of variable names or an array of variable numbers. So in this example, I increased the character size to 1.5, and you can see on the plot it definitely increased the character size. And one thing that I should note is that the options command supports all the options that the plot procedure supports. So if you have any questions about how to set an option on a plot, when I have that question, I pretty much always go to the IDL help, the plot procedure help. So when you search the IDL help, there's going to be plot, but you really want to go to plot procedure. This plot function is the newer plot stuff, but Tplot uses the older plot procedure. So you can see all the various graphics keywords. All of this, I think we used X margin earlier, but pretty much everything in this list can be set using options on tplot variables, and I'm going to set some more in a second. But this is a good place to go if you have questions about like how to change the plot, because you're just changing it the exact same way in here. You're just using the options command to set it on a tplot variable. So for instance, you can add titles to the panels using options. So in this next example, I add an FGM title to the FGM data and a DIS title to the energy spectra data. So you can see the title is on top of the plot. So in this example, the DIS title is actually going into the FGM panel. So the way to fix that is to add a gap between those two panels, and turns out there's an option for that called Y-gap. And so you call tplot_options, give it the option Y-gap, and the second argument is the number of characters. So I just said 3 characters. It should be enough. And you can see it actually adds a Y-gap of 3 characters between each panel. So if we had more panels, it would add a consistent gap between each panel. And you can see now DIS is in its right place, but FGM is still almost off the page. So we can also, as we set the X margins before, we can set the Y margins using tplot_options. And that'll bring the FGM down a little bit so that it fits in the figure. And so there's also Tplot options has a keyword called version, and what that does is change the plot labeling on the time axis. So the default is to have seconds and then the date and the start time and then the seconds here. You can change that to essentially add, so you can change it to version 1, which is this new format where it says UT time seconds after and the time. It's much clearer. And then there's version 2, which doesn't have that start time, just the number of seconds. And I think the default is version 3. Let's try it. Yeah, so I went ahead and changed the default back, or changed the plot back to the default. And all the global options that you set with tplot options can actually be found using the help command, or the help keyword to tplot options. So if you just give it tplot options /help, it'll print out the current structure for all the global options. And just as another example of how you could set the options, pretty much all of the plot options you could possibly want. I'm going to change some of the characteristics of the FGM data, so in the figure. So in this example, I'm going to tell it to use options to change the FGM data to have a line style of 5, which I think is dashed. So after that, we just called tplot to update the plot window, and you can see the FGM data is now dashed. And again, you can go to here and search for line style, and so these are the long dashes, but you can use any of these others and it'll just work with it. So you can see we also have minor ticks in the top panel. We actually have minor ticks on both the panels, but we could remove just one of them by, again, calling options on the variable in that panel, and then say y minor 1. I think y minor 1 is the one that turns them off, but just to be sure, you can always search the current page. Let's see. Actually, let's see, tplot and y minor. Because so yeah, so if you set that to 0, it will automatically accept the number of ticks, but if it's 1, then it's it turns off the minor ticks. So in this example, yeah, those minor ticks disappeared when I set that equal to 1, then replotted the data. You might notice that on line data, like on this vector, we have labels for each line. You can change that using options and then the labels keyword. These are usually set by the load routine when you load in the data, with the idea of it should just automatically work. But say if you wanted to get rid of the GSM, you could call options with the labels keyword and set it to bx, by, bz, and call tplot to replot it. And you can see the labels were updated to bx, by, and bz. And there's another keyword in options called lab flag. What this does is change the orientation and the plotting of the labels. Lab flag 1, I think, will plot what you're seeing here with bx on the bottom, by, and bc on top. One of the options, I think it's lab flag 0, will just have the labels right next to the lines. And I think sometimes that would bunch them up and they'd be overlapping. So I usually use lab flag -1, which is the opposite. It actually brings bx to the top and bc to the bottom of the list. So that just flipped our list of labels around. Now bx is on top and bc is on bottom. And so you can also update the y-axis titles for a variable. You can notice that in this, the FGM variable is labeled pretty well. It's just MMS FGM. But the DIS variable has lowercase MMS and lowercase DIS, and it essentially took the variable name from the or the YTitle from the variable name. So in the next example, I'm gonna update the energy spectra YTitle to be capitalized and have MMS1 DIS energy spectra, and the C here, the exclamation point in C, means carriage return, means to drop it to the next line. So the first line should be MMS1, second line DIS, the third line energy spectra. And you can see now the energy spectra YTitle has been updated with the MMS1 DIS energy spectra. And you can do the same thing with the ZTitle. The ZTitle is this color bar label. Notice how the load routine actually loads the units as per cm caret 2. So you can actually make the caret 2 a superscript using the exclamation point U, which tells it to give a superscript, and then exclamation point N, which tells it to drop down. So in this next example, we just go ahead and set the ZTitle, and you can see it updated the units. And now instead of having caret 2, it actually has the 2 as a superscript. Another pretty useful attribute from options is to set the color bar, essentially change the color bar. By default, we use this SPEDAS color bar, but you can also change it using the color table. And in this example, I changed it to color table 74. I just picked one at random here. And you can see it updated the color table. It's in your number 74. And another useful option is reverse color table. So this will flip the essentially just reverse the color table, make the reds the top and the blues in the bottom. So you set that option and call tplot, and it reversed the color table. Let's see. We also have the ability to set the y-axis range and the z-axis range. You can set those with options, but we have a shorthand routine for doing it called ylim and zlim. And these are the routines that we usually use. So the first argument is the variable name that you want to set the y-axis range for. The second argument is the lower range. The third is the upper range, and the fourth is the scale. So the fourth argument is either 1 or 0. 0 for linear scale and 1 for log scale. So in this next example, we're going to change the energy spectra, the y-axis, from 1 keV to 30 keV, and keep it on log scale. You can see after calling tplot, we now have a y-axis range of 1 keV to 30 keV. And so just like ylim, you can call zlim on the essentially the color bar limits. And so if you set the second and third arguments, the lower limit and the upper limit, to be the same variable, then it auto ranges. So if you set it to 0, it just does it auto scales it. But if you set that last one from 0 or from 1 to 0, it actually changes it to linear scale. So in this next example, we're going to change the color bar to linear scale. And so the range came from auto scaling, since we used the same values here, and essentially all it did was change from log scale to linear scale. And we could change it back using the exact same format, just giving it a 1 as that last argument instead of a 0. And so another thing to note is that Tplot also supports it supports wildcards, so you can do stars or question marks. And I think most of these routines also support wildcards. And for those of you who aren't familiar, question marks essentially say one character. So if you have 4 question marks, it means only plot the variables with 4 characters right there. So in this next example, when we called what was plotted first were the variables with 4 characters, which is the DES energy spectra with 4 characters, which turns out to be, should be the anti-parallel, the perpendicular, the omni. And then we added notice I used the add keyword here to add the energy spectra variables with 3 characters here. And that's just that parallel variable. And so the parallel one should be at the top, the anti-parallel should be second from the top, and then perpendicular, and then omnidirectional at the bottom. So that's pretty useful. So knowing how to use the question marks and the stars and variable names can be pretty useful if you want to, especially if you have a lot of variables loaded. So on to Tplot tools. One of the more recent tools I added is called Flatten Spectra, and what this does is take a current Spectra plot and turn it into essentially a line plot for the spectra at that time. So just to give an example, what you do is call Flatten Spectra, and in this example I used the ylog and the xlog keywords just for the output to be in log scale. So when you call Flatten Spectra, it allows you to select, it opens up crosshairs on your plot so you can select the time of interest. So let's just select right here, and you can see what it did was create another plot that shows the energy spectra at the time that I clicked, which turned out to be 22:34:02. And it has the exact time at the very top of the panel. And each line is labeled in the legend here, so it actually took the spectra from each panel and added it to the plot. So we have the parallel spectra, the anti-parallel spectra, the perpendicular spectra, and the omnidirectional spectra at this exact time. And Flatten Spectra actually has a bunch of keywords for controlling things. You can set the number of samples that you want to average, the window to average over, tell it to center the times. You could save PostScript files, save it as ping files. And so in this next example, you can see that there's a large peak just below, is that 100 EV? So in the next example, I'm just going to plot an X range of 100 EV to all the way up to the maximum. And I'm also going to average 10 samples. So we can say click there. And you can see it created the line plot of the energy spectra, essentially energy on the y-axis, or energy on the x-axis, and flux on the y-axis. And you can see the parallel is the lowest, so that makes sense because there's appears to be a dropout around the time that I actually selected. And another routine that allows you to interact with Tplot windows called Tlimit. This allows you to zoom in to a current Tplot window. So in the next example, we're going to plot FGM data and energy spectra data and call it just Tlimit without any arguments. And what that does is open again this the ability to select, actually Flatten Spectra allows you to select one time to create the spectra at T Tlimit allows you to select 2 times, and it zooms into those 2 times. So we're going to click 02 and then 08, and it should zoom into those 6 seconds. Yeah. So now it's only plotting 02 to 08. And if you know the exact times and would rather not have to click on the plot, you can also call Tlimit with the times as a 2-element array. So in this example, in the next example, we're just gonna call Tlimit and zoom out to these 8 seconds after 34. Right, and you can see now we're zoomed out to the 8 seconds that we requested. And if you want to reset to the full time range, you just give it the full keyword. So Tlimit full. And you can see it went ahead and updated the plot to the full time range of the data. So another useful tool is to add a bar, just a vertical line at a certain time. So we have a routine called Timebar that allows you to do that. So how it works is you just call Timebar with the time that you're interested in adding a bar to. And in this example, we are calling Timebar twice with two times to create 2 vertical bars. And you can see it just went ahead and added the vertical bar at 03 and 06. And you can use the same routine to add horizontal lines. The thing about horizontal lines is you have to give it to a specific variable, and you have to give it the keyword data bar so that it knows it's a horizontal line. So in this example, we set a horizontal line on the FGM variable with the var name keyword, and it's going to be at 0.0. And Timebar also accepts a bunch of the plot keywords like line style. So in this case, we're going to set a line style of 3. And I think that's it's one of those funny dashed ones. Yeah, so after calling that, you can see the FGM data now has a bar at 0. And the bar is a line style 3. We could do long dashed again like we did with the FGM data, just by setting a line style equals to 5. And so another useful routine is to interpolate data interpolate data in one data set onto another, the timestamps of another data set. So for doing that, we have this routine tinterpol. So it's like interpol except with t at the end. And the first variable is the variable that you want to interpolate, and the second is the variable that you want to interpolate onto. So in this example, we're calling tinterpol on the energy spectra variable and telling it to interpolate onto the FGM timestamps. So that created a new variable called essentially with the same variable name as before, except there's an underscore interp at the end. So we can go ahead and add that 179. Use the add keyword. So now we have the interpolated DIS energy spectra on the top. And another useful routine, if you have a variable loaded and you want to check if you have data within a certain range or time range, we have this routine or this function called SVD Data Exists, and that returns 0 if the data doesn't exist and 1 if it does. So since we have the interpolated data in memory and the data exists between these two, the start time and the end time, it returned 1. But if the data didn't exist, let's say if we gave it a bad variable name, it should be 0. Or if you give it the correct variable name and you give it the wrong time frame, it should also give 0. Say, since there's no data from 2015 loaded, we can change that, and it should still be 0. So you can use the Tnames function to find out if a variable is actually loaded into memory. And then you can use SVD Data Exist to find out if there's actually data within the time frame that you're interested in that data or in that variable. We have a bunch of other routines for or tools for operating on Tplot variables, like tsmooth, which creates a smooth variable from a Tplot variable. So in this example, and I'm using the number 2 version. I'm not sure if there's a number 1 version, but let's actually see if there is. Yeah, there's not. For some reason, the routine for smoothing a Tplot variable is called tsmooth2. So you give it the name and the width that you want to smooth over. And this example, I think we're smoothing over 6 seconds. So it created a new variable called, so it's the same name as before except _sm for smooth. And I went ahead and plotted the smoothed FGM data along with the energy spectra. And you can notice that the Y minor, the minor ticks, are still gone. Like all of the metadata from before that we've been operating on, we've been carrying them along in the Tplot variables. It's one of the beautiful things about Tplot being object oriented. It keeps all that metadata with it as you work with it, with all the various tools. Another useful tool is SVD Tplot average. This will create the average, or actually calculate the average within a time interval. So for instance, if you pass the number density and your start time and your stop time, it should calculate the average number density between those two. So you don't have to use get data to extract the data at all. You just call Tplot or call SVD Tplot average, and it averages it. There's also a routine for subtracting the average from the data, and it also allows you to subtract the median. It's called tsub average. So, and what that did was went ahead and created a new variable, essentially with the same name as before, except with a -m, which means the median was subtracted. And finally, one of the most powerful tools that we have for working with Tplot variables is called calc. And calc allows you to do calculations on Tplot variables without having to extract the ideal data structures. I'm going to be showing a real simple example here, but there is a crib sheet under general examples and crib_calc, and that has a lot more examples and shows a lot more of the nifty features. So in this next example, I'm just going to calculate the number of, I'm going to convert from kilometers to Earth radii. And so we have some mech R data, essentially position data in SM coordinates, and we want to calculate it in Earth radii. So this is the variable in SM coordinates. We can check if this data is actually loaded by calling Tnames and giving it the variable. You can see it returned the variable name, so it's actually in memory. So you just call calc, and this variable is not going to exist until after we call calc. But notice that all Tplot variables and calc scripts have to have double quotes around them. So let's go ahead and run this example. See the first line here created a new variable called MMS1 mech R SM RE. So this should now be in Earth radii. So we can actually go ahead and add that to the plot. So 182. And you can see now the top panel on the figure has the X, Y, and Z components of the position, and these are in Earth radii instead of kilometers, just because we divided by the Earth radii conversion. And so another useful thing with Tplot is to use the VAR label keyword. What this does is allow you to change the labels or add labels to the bottom of the plot. Essentially change from using, in addition to using time, you can also plot other variables that are changing, such as in this instance, position. So, for instance, we plotted the B field data and the energy spectra and told it the VAR label is the position data. It should create, so we have the position, we have the FGM data on top, the energy spectra data on the bottom, and then at the very bottom you have the times, but then we have the X, Y, and Z components in the just above time. And you can tell they're not changing very much. That's because this is only just a few seconds, or it's like a couple minutes out of the day. So we're not really changing that much when it comes to REs. And you can change the these labels over here using options and ZTitle. So let's go ahead and try to change that. And you can see it went ahead and updated the options. I think so. You can also update the options on each individual label and have it say RX and RY and RZ. So I guess that's pretty much how you manipulate plots. I think it covers pretty much everything you could possibly want to do, especially when you can consider that you can go to IDL help and go to the plot procedure. Remember the plot procedure help page, and this has essentially all these settings you can set for any panel or figure. So next we're going to go on to exporting the data from Tplot. So first I want to mention the Tplot _ GUI. I don't think this gets a lot of use because most people don't know about it, but you can import data from Tplot variables into the SPEDAS GUI just by calling Tplot _ GUI. So I gave it the two variables and it went ahead and loaded the GUI and allows me to verify that the units and the coordinate systems and everything. And then click OK, and it went ahead and imported the panels. And so that's the first way to get data out of Tplot variables. You can just put them into the GUI. Another way is to save them to a save file, an IDL save file. And to save a Tplot variable to an IDL save file, you just use Tplot _ save. The first arguments are the Tplot variable names, and you also need to give it a file name keyword. So in this example, we're going to save the B field data from before and the energy spectra data from before in a save file called MMS _ Data. So went ahead and saved that. Let's go make sure it's actually there. Yep. So it appends the Tplot _ save appends the .tplot extension onto the file name. But this variable should have all of that data. So to show that, we're going to call del _ data, and we're going to delete all of the currently loaded data. So just to show that we actually still have a bunch of data loaded, called Tplot _ names, and it shows our 182 variables. So if we call del data with the star, and that deleted all 182 of our variables. Now you can call Tplot names again and don't have any variables loaded. So we can restore this Tplot save file just with Tplot _ restore. And in this example, we actually do have to give it the file extension, the .tplot. And that should restore those two variables that we had saved. So we can now try plotting them. Should be and plot it again to resize it. And notice this time we only have these two variables loaded because those were the only ones we saved in our save file. And notice that it got the metadata and everything is still correct. So the next way to export the data is to ASCII files. I've actually been asked about this a lot. It's super simple. All you have to do is call tplot_ASCII and then give it the variable names. And you can give it a single variable name or an array of variable names. So if you give it an array of variable names, it creates an ASCII file for each variable. So in this, it created one for the energy spectra data and one for the B field data. So you can see now we have so here's what the ASCII file actually looks like. This is the B field. You see we have the timestamp first, and then BX, BY, and BC. And here's the energy spectra as an ASCII file. And it's not as pretty because there are 32 channels instead of the just 3 components. But the data was saved as an ASCII file. And another useful keyword to tplot ASCII is the tRange keyword. This allows you to specify or limit the time range of the output data. So for instance, actually let's come over here. Make sure this actually works. So the first time in the FGM file is 22:33:03:30. So, oops, should just continue. So I think that should have updated this file with a limited time range. Yeah, it looks like it's a very slightly different time range. But you can essentially change this to say, I don't know, 33, say 40. And should limit it even further. Yeah. So another way of exporting data is to save the tplot variables directly to a CDF file. And for that we have tplot to CDF. And one important keyword here is default. I keep forgetting what that actually means, but it's always required. What it does is set up the default metadata and internal structures to save the CDF file. And so it's pretty much always required. And you have to give it a file name to actually tell it what the CDF file name is. And then tvars is an array of tplot variables to save to the file. So in this example, we're saving a CDF file called MMS Data.cdf and saving the FGM data and the energy spectra data. You can see from the output in the console, it saved the file. And we could, just as an example, come over to autoplot. Just open autoplot. And you could go to File, Add Plot From, Local File. And it should be at the top here, MMS Data. So we can go ahead and plot the B field data and autoplot. So you can see that it saved the CDF file fine, and maybe go ahead and plot the energy spectra below. So it probably didn't get some of the attributes, the metadata attributes that it should have. For instance, the color bar should be on a log scale, not a linear scale. So we'll have to look into why that is. And it looks like the y-axis here is something wrong with the y-axis titles. So Tplot to CDF is definitely still a work in progress, but it's coming along. And finally, we have you can export directly to Autoplot without having to go through all of that. Let's go ahead and do that. I'm going to open a new version of Autoplot. So internally, this routine Tplot to AP will actually send the data directly to Autoplot from using CDF files. So you don't actually have to call Tplot to CDF directly. All you have to do is go to Options, Enable Feature, Server, and just enable it on the default port, and then call Tplot to AP on the variable names that you want to import into Autoplot. And it sends the variables over. And Tplot to AP actually gets the metadata correct, or it should, because it manually sets the metadata from the metadata and the Tplot variables over the interface with Autoplot instead of saving the metadata to the CDF file. So you can see that the y-axis title that we set using options was actually sent over as well. So was the correct label for the energy, or the table, or the color table, the color bar. It even got the superscript 2 on centimeters correct. So finally, saving the image files. So if you want to save image files, there's a bunch of different ways to do it. There's two main ways. The main way that most people use is make PNG, and that creates a PNG file with the current Tplot window. So in this next example, we're gonna call make PNG and give it the variable, or the file name. And I also showed some of the other make routines, like make GIF, which makes a GIF file, and make JPEG, which makes a JPEG file. I think most people use pings, but those other routines exist as well. So we can see, so we have the ping here, and what that did was that ended up saving the other window that I didn't even know we had open here. So I think make ping accepts a window. Yeah. So this is Windows 0. And since we have two windows open, it's using the latest one, which is Windows 1. But what we really want is Windows 0. And so that should have created a make ping with Windows 0. And so the JPEG is still at Windows 1, but you can also do the same thing with window equals 0. And it should create a JPEG of Windows 0. Yep. And finally, you can save PostScript files using the tprint keyword. I think some people are familiar with the internals to tprint. That's the popen and pclose. I've seen scripts where people are using popen and pclose to create PostScript files. It's probably better to use tprint because it adjusts things for like the Timebar. It allows you to save a PostScript with Timebars as well as the data bar. And so you just call tprint with the file name, and then if you give it the landscape keyword, it'll make it landscape mode. So here, so this created a new file called MMS_data.ps, should be the plot and postscript and landscape mode. So there's the postscript file. All right, so that's pretty much all I have. I think it should get you started, or should be plenty to mull over for a while. If you have any questions, feel free to email me. And again, this script is going to be, or it's actually in the latest bleeding edge zip under projects, MMS examples, webinars, Tplot Essentials, MMS, Tplot _essentials _MMS _aug18. And that actually fits most of the other webinar formats that we have here. Let's see. Just want to show the trunk. So when you have SPEDAS, you go to projects, MMS, examples, webinars, and there are actually a bunch of different webinars in here from before. See, that's an older version. But you have the Tplot Essentials webinar, and we also have all these others like the SPEDAS, the plasma instruments, the particle instruments, the flipbook, the fields instruments, and EIS and FEEPS webinars in there as well. So if there aren't any questions, yes, thanks for calling. And feel free to email me anytime if you have questions later. I'm always happy to help. Thanks.